Hello, good morning friends. Welcome back to your favorite channel Code One Digest. Today in this tutorial, we'll understand what is circuit breaker pattern in software design, how it helps us in enhancing the system resiliency, and we will also implement circuit breaker pattern with an example. I'll show you step by step how to implement circuit breaker pattern in your project. So stay tuned and watch this tutorial till end. It is going to be very informative, very useful video. Today in distributed system, circuit breaker pattern plays a very critical role in preventing the cascading failures. So let's understand step by step what is circuit breaker pattern and how to implement it. Okay friends? So here is the agenda of the tutorial today. We'll understand what is circuit breaker pattern. I'll give you the introduction of circuit breaker pattern, how circuit breaker pattern works, then what all implementation strategy and configuration we can consider for circuit breaker pattern, what are the benefits and real world applications of circuit breaker pattern. So this is the theory part of circuit breaker pattern. Then come next to a implementation part of circuit breaker pattern where we'll be implementing circuit breaker with example. I'll explain you the architecture of circuit breaker pattern, a very simple architecture. We'll be coding a circuit breaker service, and finally we'll be testing. I'll be showing you the demonstration of circuit breaker pattern. Friends, if you are already aware of pattern and if you feel that theory is not important to you, you can directly jump to the implementation part of this tutorial where I'll be explaining you, showing you how to implement circuit breaker service and how to run and test it. Okay, so you can skip the theory. If you are new to circuit breaker pattern, then go to a theory and then go for implementation. Okay, friends? Okay, friends, so now let's start and understand what is circuit breaker pattern. Let me give you introduction of circuit breaker pattern. What is the purpose and necessity of circuit breaker pattern in distributed systems? The distributed systems often encounter network failures and service outage impacting reliability. In distributed systems, one component calls other component through microservices or APIs. If any of the API or microservice goes down, then it creates a cascading failure to the calling service. Hence, the whole applications experience a failure. Therefore, we use circuit breaker pattern to prevent that cascading failure. The pattern detects fault early and stops the problematic processes to prevent system-wide failures. The common problem is addressed by this pattern are cascading failure mitigation, resource exhaustion prevention, and latency spike detection. Let's understand all of this. As I explained, if one service goes down, hence the calling service experiences a failure and start retrying it. That cascades to multiple microservices and the whole application experience the slowness. All of the services goes into retry mode. Hence, it exhausts a lot of resources and our application experience slowness. It also increases the latency because the dependent services are not responding. Hence, the calling service response time increases. So solution to all this problem is the circuit breaker pattern. Let's understand how circuit breaker pattern works. Circuit breaker pattern consists of three main states. Let's understand all of these states one by one. Circuit breaker is in closed state when there is a normal operation where all the calls are going through without interruption. When circuit breaker pattern is in open state, that means it is blocking all the calls to a dependent service or third party service. It preventing further operations to avoid any failures. Half open state is a state allow trial calls to test system recovery before fully closing. What does it mean? When all the services are responding fine, then circuit breaker pattern will be in a closed state. If it detects that one of the service is not responding, then it opens the circuit and it prevent from sending any call to the failure service. Then after timeout interval, it goes into half open state where it sends a limited number of calls to the failed service to test if the service recovery has happened. If it gets a response successfully, then it closes the circuit. Right, friends? And we'll see that in detail in a coming demo. Friends, before we proceed in this video, I request you to subscribe this channel to grow Code One Digest family. Friends, I am creating a lot of quality videos on programming, coding concepts, design pattern and design principles, cloud and container technologies, but I'm not getting subscribers. I request you to like, share and subscribe this channel so that I can grow our Code One Digest family. Thank you. Let's understand the state transition and triggering mechanism in circuit breaker pattern. So there are two ways the circuit breaker pattern can trigger. One is failure based threshold and second is time based threshold. These are the configuration part of your circuit breaker pattern or circuit breaker service. Failure threshold triggers exceeding the failure threshold. Let's say you have set up the number of failures. If the number of failures are more than 50% or if the number of failures are more than 60%, then trigger my circuit breaker pattern. Another configuration is the timeout. When the circuit is open, then it check for this timeout configuration and wait for that amount of time. After that timeout, it move into a half open state to test if it can return to a normal operation. After timeout, sends a limited number of requests to a failed service and check if the services are up and running. If services are responding, then it close the circuit and come back into a closed state. We'll understand this in a demo and in the architecture diagram. So what are the implementation strategies and configuration parameters we have in circuit breaker pattern? So these are some design consideration and configuration we have in circuit breaker pattern. As I said, we have a failure based threshold. This tells us when to trip our circuit breaker after 50% of failure, after 80% of failure, or after 20% of failure, so that we can configure. Timeout is a duration when it waits for that interval for it to move into a half open state. And third is the fallback strategies. If the circuit breaker is in open state, then this fallback method to respond back to the calling service with the appropriate message so that calling service act accordingly instead of waiting for a response from a field service. We'll see this configuration in our implementation. There are libraries and framework available like Opossum, Hystrix, Resiliency 4J, and Poly to implement circuit breaker pattern. This library offers configurable options that simplify the adoption and integration of circuit breaker pattern. What are the benefits of circuit breaker pattern and real world application? Major cloud providers today implementing circuit breaker pattern to ensure robust and reliable service delivery. And many e-commerce platforms rely on circuit breaker pattern to maintain uptime and handle the traffic spike effectively. In conclusion, circuit breaker pattern is crucial in modern software design for managing the system fault gracefully. Proper implementation of circuit breaker improves the system reliability and robustness in distributed environment. Using circuit breaker pattern leads to a better user experience by preventing cascading failure. So we have completed the theory part of circuit breaker pattern. Now we'll move to a implementation part of circuit breaker pattern. Let's proceed to implementation of circuit breaker pattern in NestJs framework using Opossum library. Let's understand the architecture and working of circuit breaker pattern with this sequence diagram. On left hand side, you can see we have service A, service B, service C, and service D. At any moment, if service D goes down, then service C start experiencing the failure and doesn't get a response. Hence, service B depends on service C and service B also started experiencing the failure because service C is not responding with the data. And same is the case with the service A. As service B is not able to respond, then service A also started experiencing the problem. As the service D going down and it is impacting with the cascading failure of service C, service B and service A, hence all of the services are not responding and go into failure mode. To prevent this, we introduce a circuit breaker in between the services. If you see on the right hand side, we have circuit breaker, and if circuit breaker detects that any of the service is not responding, then it triggers the circuit breaker pattern, goes into open state and prevent any call going to service D, and it respond back to service C with a fallback method. Now fallback method can respond back to service C with the appropriate message saying that service D is not available. Hence service C will send that message to service B and service B send that message to service A, and whole system will work smoothly. Here, circuit breaker pattern prevents the cascading failure for all the services. Whenever circuit breaker pattern detects there is a service failure, then it opens the circuit and respond back with a fallback method. Right, friends? You understood the working of circuit breaker pattern, and now we are going to implement the same way. If you see in this diagram, this dotted box is our application, our main application, which is calling a third-party API, and my application, which is running a controller. This controller is supposed to call third-party API, that is localhost hello, to get data. Whenever circuit breaker service detect that third-party API is not responding, hence it opens the circuit and start responding to controller with a fallback message. So this is how the circuit breaker pattern helps and works in a failure situation. And we are going to implement this three classes. We will implement the controller, we'll implement the circuit breaker service, and we'll also be running a third-party API in our local as a separate application. Okay, friends? So let's do that. Okay, friends. So now let's start and create an NestJs project where we'll be implementing circuit breaker pattern. I'll show you how to create NestJs project from scratch, how to implement circuit breaker pattern in Nest.js. So let's start. Okay, friends. So very first thing that we'll do is open a terminal and you have to create a Nest.js project. So what is the command? Nest new. Okay, so this is a project. Yes, I'm going to use npm. So select that. Now it is creating all the folders and directories and project structure for me. Okay, friends. So now project is created. Now, next step is to load this project into our Visual Studio Code. And then I'll show you what all dependencies that we have to install. Okay, what all libraries are required to build circuit breaker pattern. So that will be installing it. So let's do first thing. Let's load this project into our Visual Studio Code. Okay, so this is my Visual Studio Code. So now you can see the project is loaded here in Visual Studio Code. And this is my package.json file. These are the default dependencies have been loaded by Nest.js, Nest.js Common, Core, Platform Express. Now what we'll do is we'll be using one library, okay, and we'll use that library to build our circuit breaker pattern. And it's a very good library. This library is available for Node.js, JavaScript projects. Let me show you that. So this is the library, Opossum. This is the circuit breaker JavaScript library available for Node.js. Opossum is a Node.js circuit breaker library that execute asynchronous function and monitor their execution status. We can provide a fallback function to be executed when the failure is state. So we'll see that during the coding. I'll show you that. So this is a library. Now we are going to install this library into our project. Let us do that. Let me copy this. I'll go here in my project. I'll put it. Let me take the latest one. Yeah, so it says it is installed. Let us see in our project if it is updated here. Yeah, I can see Opossum is being added here. Very good. Opossum is installed. Now next step is to install Axios library. This project will be calling an API of other system for our testing purpose. Hence, we will be needing HTTP support, Axios support to call any third-party APIs or any other APIs, right? So let's install Axios npm I Axios, right? So this is installed. Let us validate that Axios is added. Very good. And Opossum is also added. In your package.json, though we have installed the Axios library, but you also have this NestJs Axios, okay? Because we are going to use that as well, right? So please ensure that this is loaded, this is added, If it is not there in your dependencies, please add these dependencies as well and just do a npm install. So it will load all the required files for this library. Okay, friends. Now we are ready to create our module, services, and controller classes. Okay. So if you see a default structure of this project having a default controller, default module, and default service. If you are aware of NestJs project structure, then you would know that we'll be creating a new module, and then in that module we'll be creating a services and required controller and so on, right? So let us do that. Let me go back to our terminal and I'll say cod circuit. This is a command to create a new module, and I'm creating a new module with the name cod circuit breaker. Okay, let us do that. Yeah, it has created this cod circuit breaker module.ts and so on, right? And updated the app.module.ts. Okay, so let us go and see. If you see, this is the module created and it has this module class, COD circuit breaker module, and the reference of this module is imported in our global module, that is our main module. Now, next step is to create a service. You will use the similar command and will say enter. So it has now created a service class. It's a test class and also updated the module. So if you see here, inside this module, now we have service is created and respective test class is also created, and this service got added into a provider list of this module, right? So this is done. And now what we'll do is we'll create a controller. So let's create controller as well. So this is a command NestJs co circuit breaker. So it has now created the controller and controller test class and also got added into our circuit breaker module. So we can see that here. This is our controller and this controller test class and got added into this module here in controller list, right? So now we have a basic project skeleton ready with us. Now we have to put a code into these classes. Okay, friends? Okay, friends. So I have put few imports here. Everything from circuit breaker from Opossum library, HTTPS service from our NestJs Axios, and Axios from Axios. So these are the imports we have. Now what I'm going to do is I'm going to put a constructor and going to add a public function now. Okay, friends? Okay, friends. So now here is the updated service class I have. Let me explain you line by line what I have done. So these are the imports what I have. This is the interface I have added so that I have certain information in form of breaker config, and this will be used for each and every endpoint that we are going to implement circuit breaker. You may have a lot of APIs to call. Hence, I am showing you in this demo how to implement circuit breaker for multiple APIs, not just one API, but for multiple APIs. When you're calling different APIs, how to implement circuit breaker. Hence, I'm defining an interface breaker config with timeout, error threshold percentage, and reset timeout. So this with this three parameter. Now we'll use this to define for each and every endpoint that we want to call. Okay, so let's see that. This is my class. This is my main service class. Here I have defined a logger and then I have defined a breakers map where I'm putting a key and the circuit breaker. What is the breaker for that key? So this key will be the key of my endpoint or key of the APIs that I'm calling, and this is a circuit breaker, respective circuit breaker. So we initialize this map with all the circuit breakers with for all the APIs that you have in your system. I have in my system, but in this demo, I'll be showing you for the two endpoints or two APIs that I'm going to call. Okay, so you can keep adding it. Let us see the constructor. This is my constructor, and in this constructor, very first line I'm doing is defining an API config as record and again the key and breaker config. If the values are, this is my first key API1 and this is a timeout for it, that if I don't receive a response in 5 seconds, and 50% of my requests are failing, and then this is my reset time. So after 10 seconds it will try again. Okay, so this is a reset time. You would have seen this configuration in my explanation when I was explaining the theory of circuit breaker. And for API 2, I have set a timeout of 3 seconds where 40, if the 40% are failing, then it will trigger, and reset time here is 5 seconds. That means it will retry after 5 seconds. Okay, so this is a configuration for API 1 and API 2 available in this map. Okay, now the next step is I'm running a for each loop and creating a circuit breaker for each and every API. So tomorrow, if you have a third API, fourth API, you come here and add those APIs and initialize this class, run this class. So it will be taken care in this for loop. It will get circuit breaker for each and every API. So it will run for each on the config, API config, and it will create inside that it is creating a breaker, new circuit breaker with the above config. This is my API config is provided here. And here I'm saying that when you open, half open, when to open and half open and close, so it will log a message. Okay. As I explained you earlier, what is open, what is half open and close. So in those three events, it will log it here for that individual circuit breaker. Once this is done, then I'm also adding a fallback method. Friend, this is very important. When your circuit opens, that means when the API fails, then what you want to do, you put that code into this fallback. So breaker.fallback, you are adding a fallback, writing a log here that for this key, actional service is unavailable, returning fallback data. Okay, and this is a message. Okay, service is temporarily unavailable. Your handling can be different than this. You can do as per your requirement. That means the fallback will be triggered whenever the circuit is open. Okay, and then the request comes for that API. So this will trigger. Okay, this is important. If you don't do this, then this library will return with a default message with a default behavior, right? So better you override it and have a custom implementation of this fallback. So it will do that for all the APIs that you define here in this map. This for each loop will run. It will create a breaker for each and then also add a fallback method for each breaker. Breakers list. Okay, in this breakers map, it is going to set it. So this is the key, the same key and the breaker that is created here. So that is what we are doing in a constructor so that when this class initialized, this is ready with all the breakers for all the given APIs. Current demo is for two APIs. I'll show you what all those two APIs. So this is just initialization. This is just creation of those breaker. Now what happens when the actual call comes for those API? So this method I have created public async method request with breaker. I'll call this function from my controller class. So controller will be sending me the API key so that I know which breaker to invoke. Okay, so API key will tell me that and request options. So these are some request options provided. So I'll come and log it here. Then I'm getting a breaker from my the breakers map by passing a key. This is my breaker. And if breaker is not available, let's say for a given key, so I am putting an error that no circuit breaker configured. If this is fine, then I'll come here and I'll fire a breaker. So breaker.fire is a out of the box function which will actually call that API which is configured here and it will fire. So when we do fire, it checks first whether the API is available. So when we call this fire, a circuit breaker checks the state of this API, whether it is where the circuit is open or circuit is half open or circuit is closed. Based on that, it will take action. If it is closed, if the circuit is closed, then it will make call to that API. If circuit is open, then this fallback function will execute and return a message. Or if circuit is half open, then it will try to call the API again and see if if the API is really responding or not. So based on the fire, internally, this library takes care of all these activities, right? Whether the API is available or not available, circuit is open or closed or half open, all of that is taken care by this fire function. So now, when this is done, we got a response. We are returning a response.data. If there is any error in this or any exception, we are logging that exception here, right? So this is a very simple service class, and believe me, this lines of code will take care of circuit breaker implementation for your microservice architecture, for your microservice project. Okay, this is what you need. Now, let me show you how to code a controller and how to call this service function. Okay. Okay, friends. So now this is my controller class. I have added a code. So this is the controller that is going to call other APIs. So these are the endpoint. Let me explain you one by one. So I have imported my service class, COD circuit breaker service. Then very first line in this controller is this constructor where I'm initializing my service class. And then I have two endpoints here, API1 and API2, because as we have configured circuit breaker for two APIs, hence I am calling those two APIs here. In call API1, I am defining how my API1 looks like. So API1 is a key and it is of type GET, and I'll be calling localhost 8080. It can be any third-party APIs that you want to call, but I'm running another application which is running on 8080 port and having an endpoint hello. Okay, so it will call that. If there is any problem, then my circuit breaker will trigger. So this is API 1. Now API 2 is having API 2 as a key because same key we are using in our service class. It is also of type get, and here the endpoint is high, localhost 8080 high. So we'll see that if this endpoint are not reachable or any problem, then circuit breaker will trigger and will return a response from a circuit breaker, and we'll see how circuit breaker is behaving. So this is very simple controller. Let's say your application is calling these endpoints API 1 and API 2, and this internally calls external API, and these are the APIs of third party system which is gone which is going down. Hence circuit breaker will trigger and will provide you a information accordingly instead of you having a cascading failures in your system. Okay, friends. So this is my controller. Now let me quickly show you where these endpoints are running. Okay, friends. So this is the simple application which is running in Node.js, and I have only hello as an endpoint here, which is going to return hello world. This is just a hello world controller, I would say in Node.js. I'm going to run this and it's going to run on 8080. It will have a localhost hello as an endpoint, but I have not defined high here. Hence, my circuit breaker will trigger for high endpoint. As we are using that, as we are calling the high endpoint here, and it is not there, it is not running in 8080. Hence, my circuit breaker should trigger. And I want to demonstrate how circuit breaker will work, right? And these are the API 1 and API 2 keys that we are referring here in our service class, API 1 and API 2, and what are the circuit breaker configuration in terms of timeout, in terms of threshold percentage, and so on, right? Okay. So now it's time for us to run both of these application and test our circuit breaker. Okay. So first I'll run this application, this server.js, so that my localhost 8080 works. Let me do that first. This is our third party API, which is running in my local right now, just for demo purpose. So I'll run this first, and then we'll be calling this API in our actual project. Okay, so let me run that. This is my Node.js application, and I have to run this node server.js. So it says server is up and running at 8080. Let us quickly test that. 8080 hello. All right. Yes, so hello is working. It is giving me a hello world string, but hi, there is no hi endpoint, hence I am getting cannot get hi. Okay. So we'll test both the scenarios, right? So this API is up. Now it's time for us to run our actual project. So this is my project. Let me clear everything. Now the command to run is npm run start. So this command you will get it from your packet.json file, and these are the script you have, and there is a start command. Okay, so we will just say npm run start. Okay, friends, so if you see, the application is started successfully. Okay, and it is running on port 3000. Let me confirm that because we have not changed that in our main.ts. Okay, so this is my main.ts and it's running on 3000. Now what we'll do is we'll be calling this controller and we'll call API1 first. Okay, let us do that. So let me go to browser, HTTP. You can also use Postman if you have. I'm using this codcb and API1. API1, yeah. So it is giving me a response. You see API1, hello world. I got a response. Let's see a log, right? Requesting data with circuit breaker, right? So it is calling that. And now if I call API2, what happens? Let's see. I didn't get a response. Let us see the logs. API2 breaker open because API was down. API2 is not available. Hence, this breaker got open here, right? API2 external service is unavailable. This is a message written from the fallback. Okay, this is returning a fallback data. And after 5 seconds, if you see, this happened at 47 and at 52, it is half open. So it will send limited number of requests to API2 and see if it is working, if it is available. If it is available, then it will close the. I will define another endpoint here as a hi and will return hi world. Okay, we'll restart that application, right? And now I'll hit this API2 again and see what happens, right? So I got a response and let's see a log of a circuit breaker, what it says. So it says, so we called here requesting data for circuit breaker. We got a request here 2806 and it says API2 breaker closed. That means this API is available to serve us. The third party API2 is available to serve our request. Hence the circuit is closed and it's available. So now I can call n number of time API2 and it will keep giving me a data, or I can call API1 and it will keep giving me a data, right? So every time we call API1 or API2, it is calling a circuit breaker, checking the state of that breaker for that API, whether the circuit is closed. If it is circuit is closed, then it is calling that API, third party API, and getting a data. So the data that you're seeing, API1 is a key, and this is the response coming from that API for API1. If I call API2, so this is the response hi word, the response coming from API2. Let's assume we shut down our third party application, the third party system is down, and now I'm calling API2, no response, and I'm calling API1, no response. Let's see the log of our circuit breaker. So here API2 was down, circuit is open, API1 is down, circuit is open, and you see here API2 circuit breaker half open at after 5 seconds and API1 breaker half open after 10 seconds because that we have configured here in our service class. If you see, this is the time for half open at 10 seconds is a half open time for API1 and 5 seconds is a half open time for API2. So it is half open. Now let's say the service comes up again. Let me start the service. Now third party service is up. Let us hit the service again. Let us hit the API1. Let us hit the API1 again. Yeah. So I'm getting a response. Now let's call API2. I'm getting API2 response as well. Now see the log. It will say the API 1 breaker is closed and API 2 breaker is closed. Hence, the circuit breaker is working absolutely fine. Let's say if any of your API, third-party API that you are calling is down for some reason, then the circuit breaker will be a savior for you because it will not let the failure cascade to your application, to your microservice. If their APIs are down or performing slow or having some infrastructure issue or not responding in time, hence circuit breaker will prevent your application, your microservices, your application from having a cascading failure. Otherwise, it will keep waiting for the API to respond, third-party APIs to respond, and it will never get the response. And that's where the performance of your application degrades. As there are too many requests coming, and the too many requests are failing, and they're not able to get the data timely. That's where our application gets slower and busier, right? So the circuit breaker checks the status of the API, whether circuit is open or closed or half open. Based on that, it responds to you. If it is closed, then it will make call to third-party API. If it is open, then it will return you a fallback message saying that service is not available. Hence, your application will handle that fallback message accordingly, show error message to or meaningful message to the user, and your system will continue running. It will not go into a deadlock state. Right? That's the whole purpose of circuit breaker pattern, that our application, my application is not going into a deadlock state where I'm waiting for third-party API to respond, right? I hope the concept of circuit breaker is clear and the implementation of circuit breaker is clear to you. In this simple service class, you can implement a circuit breaker pattern using this library, Opossum library, right? And it will take care of triggering the circuit breaker pattern, maintaining the state of breaker, circuit breaker for each and every API. Right, friends? Okay, friends. Now let me quickly summarize what we learned in this tutorial today. We understood what is circuit breaker pattern. We understood how circuit breaker pattern works, what all different state it has, like open state, closed state, and half open states. What all implementation strategies and configuration we have, like error threshold or failure threshold, timeout configuration, and fallback mechanism. We also saw the benefits and real world application of circuit breaker pattern. Then we saw circuit breaker implementation with example using NestJs framework and Opossum library. I hope you like this video. If you like this video, so give it a thumbs up. And if you're new to the channel, so do subscribe to my channel to grow Code One Digest family. Thank you. Friends, if you like this video, so give it a thumbs up and subscribe to this channel for the more interesting videos. Click on the bell icon for the latest video notifications and do not forget to share this video with all your friends and colleagues. This is very useful information for students, beginners and software engineers. I am putting a lot of efforts in creating these contents. So please help me growing the Code One Digest family. Please subscribe to Code One Digest channel for the latest programming and technology related videos. Thank you.